I'm just trying to find.
Only when you zoom in. No, I died. No, I died.
Okay, let me go over the calendar real quick, and then we're going to start reviewing for our quiz. So today we're doing quiz review. Tomorrow we're having a quiz over identities. We started on the quiz review. We'll get a chance to finish it today. Tomorrow we'll have a help session during fourth period. If I can get that review worksheet created, I'll try to send that out and send you a link through Remind. Okay. Wednesday through Friday, we are just going to be doing notes. When we come back from break, we're going to have a quiz that Wednesday and then the test the following Friday. This is the 10th, will be the last day, guys. 10th will be the last day that we have actual class. This final week, I'm just going to use this as time for any students who want to do any recovery or any makeup. Okay, so that's I'm going to reserve this final week for that. Okay. Nice.
What's the rule for finals again?
There's no finals.
There's no. What about the end?
I'm sorry.
Are there are there midterms? Okay.
We have a test that the 10th, but the second part of Unit 4. That's it. So there's no cumulative. Sorry.
Do we have to come to school for 317?
Here I'm still gonna take attendance, but you could take a virtual day. There's that option. But yeah, I'm still taking attendance. I think I'm still required to take attendance, but I'm not going to do anything new. So you don't have to. You're not missing anything if you're not going to be here. Okay, so a couple of notes about tomorrow's quiz. First is that I will give you a blank unit circle, but you're going to have to be able to fill that out and be able to use that. Okay, so I really want you guys to, and also, I mean, next year you're gonna. That's one thing that we ask you to memorize for as calculus students is that you know your unit circle. That's gonna be knowledge that you have to need on the AP exam as well. So just the one thing we ask is unit circle. So I'm gonna give you guys a chance to practice that. I'm not gonna do it in class, but if you want me to go over some of that with you, hopefully you guys are comfortable with creating the order pairs in the first quadrant. You know that all your radian measures are just going to be over 3 or over 4 or over 6, right? Over 4 is going to be the middle ones. Divided by 6 is going to be the closest measures to the x-axis, and then divided by 3 is going to be the furthest away. And you're just counting your fractions, right? You're just counting your fractions, and then if there's a duplicate, you skip it, right? You start with the 4s, then you go to the 3s, and then you go to the 6s, right? And then know your order pairs in terms of the signs, and doing it again. It shouldn't take that long for you to remember all those unit circle values. Also, the second thing is no calculators on the quiz tomorrow. No calculators, which means that if there are some messy values, I'm going to be forgiving in terms of, okay, I'm going to take minimal points off. If it's a really messy reducing expression, I'll be looking at your work for the majority of the points, right? And if it's just a minor numeric mistake because you didn't have your calculator, I mean that's minor, right? Maybe I'll take off half a point or a point, but you won't. The majority of the points is going to be based from your knowledge of the material. Okay. So I think we started our quiz review. So we're on page 5. And let me recap those problems, and then we'll finish off the rest of the review sheet here. Okay, so if you guys go to page 5 in your packets. Okay, I think we did number 1 and 2. Let me just recap them, though. So the idea here is that we are trying to break a measure that we don't recognize into measures that we do recognize. So if we're trying to break 105 degrees into something that we recognize, we want to think in terms of 30, 45, 60, and 90. And play around with them until you find a pair that actually adds up to be the measure they don't recognize. So in this case, 45 and 60 produces 105. And then from here, we can just use the sum identity, right? Sine of A plus B is sine of A cosine of B plus cosine of A sine of B. And then once you're here, then you're just relying on your unit circle values to fill in, right? Sine of 45, cosine of 60, cosine of 45, sine of 60. Okay, same idea with number 2. Tangent of 17 pi over 12, we don't recognize that, but we can create 2 measures, or just think of numbers that add up to be 17. So I chose 3 and 14, but we could have used other combinations as well. Ultimately, we want our reduced fractions to be ones that we recognize, right? You could have done 2 and 15. I think that could work as well. But once we are able to identify that it's a sum of 2 measures, we can go through tangent formula, our tangent sum identity, and then we start making our substitutions, right? Tangent pi over 4, tangent 7 pi over 6, and then we clean it the best we can. Okay. Okay, so now let's go to number 3. Any questions with 1 or 2? Yes, question. Yes, I'll give you, well, I'm going to give you I'll give you an identity sheet that has everything that you need. The only thing is I'll put a unit circle on there, but it'll be blank. Yeah, but all the identities will be given to you. Okay. Okay, number 3, cosine of 1005 degrees. We know that we can recognize that angle a lot better if we can get it to a measure between 0 and 360. So we're just going to subtract 360. Now, I know I can probably subtract 720, right? Because that's going to be more than 2 times around the circle. I'm sorry, not 270, 720, my bad. Sorry, 10. Okay, 285 degrees. If we think about 285, what are measures that add up to be 285 that are measures that we can see on the unit circle? So if we play around with a couple of numbers here, either we can subtract the 285 or we can add the 285. So measures that come to mind, maybe we can play around with 60 degrees or 45 or 30. Okay, so 225 is a measure that we recognize, and 60, so we can go with that. So ultimately, we're just trying to play and find measures that will get to the one that we don't recognize. So this is in the form of cosine of A plus B, so we start with that. Sorry, cosine is cosine, cosine. Okay, cosine of 60 is 1/2. We know that 225 is just a variation of pi over 4. It's going to be in the third quadrant, so we know cosine is negative. Sine of 60. And the sine of 225 is going to be the same thing as cosine 225. They're both root 2 over 2, both negative. Okay, any questions with 1 through 3? Okay, number 4. We have to create our triangle here. Sine of theta equals 12 over 13. Cosine is less than 0. Which quadrant are we dealing with here? Sine is positive, cosine is negative. Quadrant 2, yeah. So we're going to go ahead and create our triangle in the second quadrant. Sine is opposite over hypotenuse. 12 is the opposite. 13 is hypotenuse. We know the y value is positive, but we know the x is going to be negative. So when we find out our x value, we've got to make sure we assign this to be a negative value. Okay, everything that we need is here. Now we can do tangent of 2 theta. That's a double angle identity. We can break that down. Okay, so all we need is tangent of theta. What's tangent of theta? Yeah, opposite over adjacent, 12 over -5. Okay, you can leave your answer in that form without a calculator, but if we were to go any further, we get it all the way down to 120 over 119. Okay, number 5, tangent of theta equals -5 over 8. Secant is greater than 0. Can we narrow down which quadrant we're dealing with here? Number 5. Okay, tangent is negative. So we know secant is related to cosine. Cosine is positive. So if cosine is positive, tangent is negative, it's got to be fourth quadrant, right? Everybody okay with 4? So we look at we can go through this little chart here, ASTC,
Oh, yeah.
right? Quadrant 1, everything is positive. Quadrant 2, only sine and cosecant are positive. Quadrant 3, only tangent and cotangent. And quadrant 4, only cosine and secant.
Okay.
Tangent is negative, secant is positive. It's got to be that fourth quadrant. Okay, so we're going to build our triangle in the fourth quadrant. All right, so careful. Sometimes these fractions may not have the sign in the right place. Right, so you got to make that decision, right? What's going to take on the 8 and the 5, and which one is the negative one? All right, tangent is opposite over adjacent, so we know it's going to be 5 and 8. Which one is the negative? Yeah, it's going to be the, yes, but just saying that sometimes either, just be careful, right? Sometimes, because negative 5/8, same thing as 5 over negative 8, you have to make the decision as to where that negative is going to go. Yeah. How do you decide? Well, if you think about order pairs in each of the quadrants, you know that first quadrant is positive, positive, right? How about something in the second quadrant? Third quadrant? Fourth quadrant? Yeah. So positive x, negative y.
Oh, okay.
Right. All right. Pythagorean theorem can help us get to that hypotenuse. So I need to expand cosine of 2 theta. You can choose 3 options. Any of the 3 options are fine. I'm just going to choose one arbitrarily here. All right, what's cosine of theta? Oh, sorry, this is not right. 30. 39, my bad. Yeah, it's getting that triangle correct. If you didn't get that triangle correct, everything else is just, you're just plugging and chugging. Okay, good. With first page. Say it again. Well, tangent is negative, so tangent can't be in the quadrant 3 because tangent is negative, right? Only tangent is positive in the third quadrant. Right. Yeah, so the ASTC represents the positive, which ones are positive in which quadrant. The rest are negative. Okay, are you ready for back page? Okay. Okay, we have two angles. We're going to create two triangles. And once we can build those two triangles, we can just call them from our sum identities. So sine of x equals 15 over 17. Which quadrant are we dealing with for angle x? Second quadrant. So let's build our triangle in the second quadrant. Sine of x equals 15 over 17. So 15, 17. Pythagorean theorem. Wait, what sign is this going to be? Second quadrant. X is going to be what? Negative, yeah. So just be careful that when you're going through Pythagorean theorem, you're always going to get a positive number in return, right? But you have to make a decision. Do I keep it positive or make it negative? Okay, let's go to our second triangle. Cosine of y equals 4/5. Y is between 3 pi over 2 and 2 pi. Which quadrant? Fourth quadrant. Cosine of y equals 4 over 5. Adjacent over hypotenuse. Pythagorean theorem. A squared plus b squared equals c squared. We know it's going to be 3, but this is going to be what? Positive or negative? Negative. Okay, cosine of x plus y. Let's build out. That will be cosine of x. So we got to deal with triangle x here. What's cosine of x? Negative 8 over 17, adjacent over hypotenuse. Cosine of y, well, they already gave that to us, so we can just copy that down. 4/5. Minus sine of x. Sine of x, they gave that to us. Okay, sine of y. That we got to get it from the triangle here. What's sine of y? Okay, any questions here? Okay, if you can do A, then B, C, and D will just fall nicely in line, right? Because you've already, well, when you get to C, I guess you got to find tangent, but B and D, you're just making sure that you're copying down your identities correctly, and then you're just pulling the ratios that we've already gathered from part A. right? Treat y as your A and treat x as your B. Okay, how do we get the ratio? So we go back to our triangle here. Sine of y, we go to triangle y, and sine is SOHCAHTOA, right? So sine is opposite over hypotenuse. So opposite over hypotenuse, -3/5. Right, SOHCAHTOA for all these for these triangles here. Okay, part C. Okay, make sure we're on the right page here or the same page here. What's tangent of x? 15 over -8. Okay. What's tangent of y? -3/4. Yeah. So those are the only two fractions you need to build this out. Cosine of y minus x. Okay, I want to make sure, can everybody see from the formula that for cosine, the negative is going to go with positive? I want to make sure that we can, because they condense these formulas in that form. So if I'm doing cosine of a plus b, I'm going to pick the sign that is above, right? So that's going to be cosine a, cosine b minus. But if it's cosine of a minus b, then that operation is going to be a positive. Okay. So cosines are flip-flops. Sine is the same, and then tangent, you got the same up top, but then the flip-flop below. Make sure we can read these condensed identities here. Okay, so which quadrant is x plus y in? So we have two measures that can kind of help clue us in, right? Cosine is positive, tangent is positive. Which quadrant is going to have cosine and tangent being positive? Quadrant. Cosine positive and tangent positive. Has to be what? Quadrant. Well, if it's 4, that means tangent has to be negative, right? Which quadrant has both cosine and tangent being positive? First one, quadrant 1. Okay, quadrant y for y minus x, we have a negative sign and a negative cosine. Negative sign and negative cosine. Which quadrant will that be in? Third, right? We know tangent is the only positive in the third quadrant. Cosine and sine are both negative. Okay, continue building out these double angles from the triangle from the very top of the page. Expand first. Yes.
How is cosine negative? This is y minus x.
Cosine is negative because the result of us going through this process, we got a negative 77 over 85.
I mean, how is just y negative when for f was x in was positive y minus x in?
Yeah, so we don't know what angle y minus x is, but we do know the sign of those measures. And sine and cosine. If we know that the sine and cosine of those measures is negative and negative or positive negative, we can narrow down, right? Without knowing the angle measure, we just look at the ratios and make that conclusion. Okay. So sine of 2x expands into 2 sine x cosine x. We find sine x, we find cosine x, pull that from the ratio from the first triangle. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine of 2x, you're free to choose whichever one you want to use. I'm going to choose this one, but if you choose another one, we should get the same answer. So numerator is negative, 1 minus a large number of 64. That's the negative, so negative over negative is positive. So these are all relating to measure angle 2x. So sine is negative, cosine is negative, tangent is positive. Which quadrant must this be in? Yeah, so this is what your quiz will look like tomorrow. Yes.
Wait, how did you know it was
Oh, question 3. Because sine is negative, cosine is negative, and tangent is positive. So that's going to have to be quadrant 3.
Oh, okay.
Yeah. Any questions? And there's still about 10 minutes before bell rings. I'd like for you guys to practice filling out that unit circle just so that you can get some additional practice. And tonight you can do another one of those tonight. Help session tomorrow, 4th period. And I'll come around and check off your worksheet.